Well, basically forever, we've known that certain molecules can totally change our sense of reality. But how? I mean, what do they actually do to the physical stuff of our brain? That is the mystery we're going to dig into today, the neurobiology of psychedelics. You know, the word psychedelic itself is a huge clue. It was coined way back in 1956, and it literally means mind manifesting. And the idea there is that these drugs don't really add something new to your brain. Instead, they just sort of peel back the curtain and reveal what's already there, showing us the hidden machinery of our own minds. Okay, so that brings us to the central question, right? When the mind is manifested, what's really going on under the hood? What does that actually look like for our neurons, for our brain circuits? What are scientists seeing? To figure that out, scientists now have this incredible window into the brain, modern neuroimaging. We're talking about things like fMRI. These tools let them watch brain activity in real time, essentially giving them a chance to follow the clues as they happen. And look, the psychedelic experience is incredibly complex. It's different for everyone. But what's so fascinating is that researchers have found a couple of really consistent patterns. Two major changes in brain activity that just keep showing up in the scans over and over. And these are our first big leads in this whole mystery. All right, clue number one has to do with something called the default mode network, or DMN. Now, in your everyday brain, the DMN is the star of the show. You can think of it as your brain's narrator. It's the part that's always thinking about yourself, your past, your future. It's the me network. But under psychedelics, something wild happens. That network starts to disintegrate. The CEO of me, as some scientists call it, just goes quiet. And when that happens, other brain networks that are normally separate suddenly start chatting with each other. And that leads us to clue number two, which is this kind of amazing paradox. So while those high-level, self-focused areas like the DMN are getting less organized, our sensory areas, the parts for seeing, hearing, and touching, they become hyperconnected. They start talking to each other in ways they never usually do, which might just explain things like synesthesia, seeing sounds or hearing colors. So let's recap our clues. We've got a quieter default mode network and a super chatty sensory cortex. Now the question is, why? To explain this, scientists have come up with several competing theories. You can think of them as models. So let's take a look at the 4 leading suspects trying to solve this puzzle. Here's a quick roadmap of what we're looking at. We've got 4 main theories, and each one points to a different piece of the puzzle. One says a sensory gate gets thrown open. 2 others are actually debating whether sensory information gets turned up or turned down. And the last one? It points to a totally different culprit, a mysterious coordination hub deep inside the brain. First up, we've got the CSTC model. This one focuses on a part of the brain called the thalamus. The easiest way to think about the thalamus is as the brain's security guard or bouncer. It filters all the sensory information coming in. This theory basically says that psychedelics fire the bouncer, opening the gates and just flooding the cortex with all this raw data it normally would ignore. Then there's the REBUS model, which takes a slightly different tack. It suggests that our brain is basically a prediction machine. It's constantly using past experiences to predict what's going to happen next, and those are our beliefs about the world. According to REBUS, psychedelics just relax those top-down predictions. And with our expectations out of the way, a ton more raw, unfiltered sensory data can flow up from our senses, which creates that feeling of seeing the world for the very first time. But here's where things get really cool, and where the science is actually battling it out. So the REBUS model says psychedelics turn up the volume on sensory information, but a competing theory, the strong prior model, argues the complete opposite. It suggests that maybe psychedelics actually reduce the data coming in from your senses. This would force the brain to fill in the blanks using its own predictions, its priors. And when it leans too heavily on those, well, that's how you might get hallucinations. Okay, our final model points to a different suspect altogether, the claustrum. Now, this is a super thin, really mysterious sheet of neurons that some scientists believe acts like the conductor for the brain's orchestra, coordinating all the activity across the cortex. The CCC model suggests that psychedelics basically disrupt this conductor, causing all the different sections of the brain's orchestra to get out of sync and just start playing their own tune. So, as you can probably tell, this case is far from closed. I mean, these models are all fascinating, but they really just highlight how much we still have to figure out. All this research is now pointing us toward even bigger, even more specific questions. Scientists are really drilling down now. They're asking things like, which exact types of neurons are being affected the most? How do these wacky changes in brain networks actually lead to long-term therapeutic benefits for people? And get this, can we build a computer model that can actually predict what a psychedelic experience is going to be like? Answering all those technical questions is absolutely critical, because they all funnel down into one single massive and kind of controversial question, a question that could really define the entire future of psychedelic medicine. And the question is this: is the trip itself necessary? Is that profound, subjective, mind-manifesting experience the actual medicine? Or is it just a side effect of the real healing that's happening on a deep neurobiological level? To put it another way, could we one day make a pill that cures depression without the trip? The answer to that question could totally change modern psychiatry. By continuing to piece all these puzzles together, the ultimate goal isn't just to understand these amazing molecules, it's to learn how to use what they show us, how to use the manifested mind, to fundamentally reshape our ability to heal it.